Hi guys, welcome back to the QSC channel. Today I'm lecturing the Physics CA quiz for week 8. Okay, let's start. Which of the following statements concerning heat insulation in the vacuum flask are true? Heat loss can only occur when the stopper is removed. Yes, this makes sense. The function of the flask is to keep it warm or keep it cold. Only if you open it, it's gonna lose heat. Okay. Silver coatings help in releasing the heat from the flask. No, we don't want to release heat, we want to keep the heat. Anyway, the silver coatings, they reflect the radiation that can penetrate the outer surface, which is what they say here. Heat loss through radiation is reduced by the two silver coatings, so yes, correct. Convection is totally prevented by the outer case. That's wrong. Convection is stopped by the vacuum. Vacuum between the double glass walls prevents conduction. This is correct. So vacuum stops conduction and convection. And radiation is stopped by the silvered surfaces. Okay, the potential difference across a 5 ohm resistor is 20 volts. The power is what? So you have resistance and you have voltage, and they want power. The rule that relates these is P is equal to V squared over R. You need to memorize this. It will be 20 squared over 5 equals to 400 over 5 equals to 80 watts. Current of 3 amperes flows in a 20 ohms resistor for 1.5 minutes. What's the amount of energy? Okay, you're given I, R, and the time. And they want energy which is work. So what do we know about all these? We know that work is equal to I squared RT. Remember, because P is equal to I squared R, we just brought the T to the other side, so it became W equals to I squared RT. Okay, so just substitute the values. 3 squared times 20 times 1.5 times 60 to make it into seconds. So you will get 16,200 joules, which will be 16.2 kilojoules, but they didn't put that, they just rounded it, so it's 260. Okay, these IV graphs, you need to memorize them. In SDP and the book, they show the graph for the diode like this, but Mr. John said that's actually like this. Wait, it should look like this. You don't need to like it doesn't matter for the computer part, but if it comes written, you have to do this part. Okay, and the ohmic conductor is a perfect straight line. There are two other graphs, which are the filament lamp, which will be like this, almost like an S shape. Okay, and the other one will be the thermistor, which is NTC actually. For what that is, you don't need to know, but just memorize it. Okay, so I V, this one will be like this. Okay, so just memorize these. Okay, two resistors of resistances 30 and 70 are connected in parallel. What is the equivalent resistance? For parallel, the equation to find the R equivalent is 1 over R equivalent equals to 1 over R1 plus 1 over R2 and so on. So you do 1 over R equivalent equal to 1 over 30 plus 1 over 70. You get 1 over 21. Now you have to flip it because it's 1 over R equivalent. So R equivalent will be 21 ohms. Okay. Okay, three resistors of resistances 15, 20, and 50 are connected in series to each other. In series, it's easy, just add all of them together. So 15 plus 20 plus 50 equals to 85. Okay, in the diagram below, the potential difference across a battery is 24 volts, and the resistance of each of resistors A and B is 10 ohms, and that of resistor C is 45. We want the current through resistor C. What do we know about current, voltage, and resistance? V is equal to IR. So I is equal to V over R. Now, you might think you can do 24 over 45, but no, that's wrong. Because the voltage of C is not the full voltage, because it's in what? It's in series with the resultant of A and B. So the voltage will actually be divided. So you can't find it. What you can find though is the total current, which is equal to the current in C because they're in series. So I total is equal to I of C. So let's find the total current. Total current will be equal to the total voltage, which is 24, over the total resistance. Now the total resistance, we need to find it. We know this is 10, this is 10, and this is 45. When you have a structure like this, you always start with the parallel first. So let's find the resultant of A and B first. It will be 1 over the total equals to 1 over 10 plus 1 over 10. You'll get 1 over 5. So R, A, and B is equal to 5 ohms. Now you add with C, because in series you just add the resistances. So 5 plus 45 is 50. So it's 50. Our total is 50. So you just put 24 over 50, you will get 0.48. Okay. Now, if you want the current through the resistor A, okay, we know that the current going in a junction is equal to the current going out, which is this and this. So basically, current in C, which is 0.48, is equal to current of A plus current of B. But look, since we have here the same resistance, 10 and 10, we can just divide it by 2. Divide the resistance. So IA is equal to 0.24 and IB is equal to 0.24. But in the case where you don't have 10 and 10, what do you do? So let's say this is 6 ohms and B is 8 ohms. So you write 0.48 equals to IA plus IB, and in parallel, what do we have equal? The voltage. So we write voltage is equal to, for A it's IA. RA, what's RA? It's 6. So 6 IA. Then for the other one, V is equal to 8 IB. You make these equal, get 8 IB is equal to 6 IA. Isolate one of them, so let's say IA is equal to 6 over 8 IB. We substitute in this equation you get 6/8 IB plus IB is equal to 0.48. This is easy, you can find it since one variable, so you just find the current that way. But since it's the equal resistance, you don't need to do all this. Okay, consider the circuit diagram shown below. What's the electrical component X called? It's a diode. You have to memorize this. No, there's no other way to know. Okay, how the current flow? They give you a positive sign here. And by convention, current flows from positive to negative. So it will flow like this, from A, C to B. So yeah, it flows from A to C to B. Also, an extra note, the electrons flow from negative to positive. So electrons are like this, current is like this, so they're opposite. Okay, a potentiometer is connected in series with a 6 voltage power source as shown below. The slider of the potentiometer can be placed anywhere between points X and Z. Point Y is at the center of the potentiometer. Okay, so they want where should we place the slider to give a 0 voltage, a maximum, and a 3 voltage. Okay, so first of all, there's a very important thing that they didn't put, which is that current is up or positive negative like this. They didn't put that. They should have put that actually, but they didn't. Okay, now we know now we can solve. Okay, so whenever the current goes up, we say that this is the positive terminal and this is the negative terminal. Basically, the positive terminal, you have the maximum, and at the negative you have the minimum. In the middle is just going to be half, so 3 volts. You can also imagine it as the positive will be like 6 and the down is going to be 0. So halfway it's going to be 3, like here it's going to be 4, and so on, like something like that. Anyway, so those are the answers. And if they told you that it's going down, then this will be the positive, this will be the negative. So Z will be max and X will be minimum. Just keep that in mind. Okay. A 1.5 ohm ammeter can measure currents up to 200 milliamperes. In order for the ammeter to measure currents of up to 10 amperes, a shunt resistor must be connected in parallel with the ammeter. Yes, you have to memorize this in parallel, yeah. And then the resistance of the shunt resistor is what? First of all, let's remember what the circuit looks like. Should be something like this. Yeah, this will be the shunt resistance. There will be a current going in, I. It will be split into two currents. This current will be I minus I full scale, and this one will be called I full scale. And there's a resistance here called I forgot what's called, but it's RC, okay? So here they want you to find the resistance of the shunt resistor, and they give you 1.5 ammeter. This resistance is what? This is RC, so RC is equal to 1.5. Whenever they give you the resistance of the ammeter, it's RC. And then currents up to 200 milliampere. This is the full scale. So I full scale equal to 200 milli times 10 to the power negative 3. And Now they said 10 amperes. This is the current that's going in. So I is equal to 10. Now how do we find the resistance? We know that in parallel voltage is equal. So you do V is equal, so the voltage of the shunt is equal to Rs times I minus IFS equals to I full scale RC. So the shunt is equal to F full scale RC over I minus IF full scale. You can memorize this rule, or you can draw it and solve the way I did. Anyway, so substitute in the values, you're gonna get 200 times 10 to the negative 3 times 1.5 all over 10 minus 200 times 10 to the negative 3. So you will get you're going to get 0.0306 ampere what's it called, ohms. So, and they want it in milli, so multiply by 10 power 3, multiply by 1000, it will be 30.6. Okay. What are the factors upon which the resistance of the conductor depends? So resistivity, length, and cross-section area. This is just from the school. So you look what rho is the resistivity, and L is the length, and A is the cross-section area. Consider the circuit diagram below that helps us to study the characteristic of a filament lamp. Which of the following are true about a filament lamp? Okay, so let's remember the first filament lamp has the graph, which is like the S. Wait. Like this. Okay. Now you can ask the questions. Its resistance increases as the current increases. So as you can see, it's constant for a while until it starts to curve. When it starts to curve, it becomes flatter, which means that 1 over R is decreasing because the slope of the IV graph is 1 over R. If 1 over R is decreasing, then R is increasing. So we can say that when the current increases, resistance increases. Okay, this is correct. This is not an ohmic conductor, this is correct, because ohmic conductors have a perfectly straight graph like this, and this is not straight. Okay, it obeys Ohm's law. Ohm's law is that R is constant for ohmic conductors. It is not an ohmic conductor, so it will not obey this law. So these two are basically the same option. Okay, its resistance remains constant? No, because it starts to bend. Its IV is a straight line? No. Okay. This is chapter 1 stuff. I'll do it anyway. So a hot piece of iron of mass 5 kg at temperature 60 is placed in 3 liters of water in a copper pot of mass 1 kg at room temperature 300 Kelvin. And they give the specific heat, and they want the equilibrium temperature. So we can say that the iron, the energy that it lost to the environment is equal to negative of the energy gained by the environment, right? So let's see what that's going to give us. So Q is equal to mc delta T, we know this rule. So iron lost, so the mass of iron is 5, so m times c, which is specific heat, which is 0.48 times 10 to the power of 3, because it is kilo, we make it into joules, times the change in temperature. The final temperature is what we're trying to find, so keep it T, minus, what's the original? It's 60 plus 273, which is 333 Kelvin. Okay, now this is equal to negative the total energy that it lost. What two things did it lose it to? It lost the heat to the copper and the water. So we're gonna do Q of water plus Q of copper. Okay, so mass of water is what? It's 3, because liters is equal to 1 liter of water is equal to 1 kg of water. So 3 times 4.2 times 10 power 3 times T minus, they were both at room temperature, so 300, plus 1 times 0.39 times 10 power 3 T minus 3 times 10 power 3 T minus 300. Now I'm not gonna solve this by hand. You can do shift solve on the calculator. You're gonna get 305.1, which you round. Okay, a student wants to conduct an experiment to determine the specific latent heat of vaporization of water, and they want the steps. This is just memorization, and it's also chapter 1. So okay, the steps are easy. Connect the immersion heater, fill the beaker with hot water, blah blah blah. Anyway, okay, then why doesn't the student use a thermometer? Because during the evaporation or melting or freezing, whatever, there's no change of temperature. When there is a change of state, the temperature stays constant. Okay, again, this is the same thing, but for latent heat of fusion. Okay, no change of temperature again. And for this one, you know that Q is equal to IVT, and also Q is equal to ML. So they made them equal, so ML equal to IVT, then they divided the M down. Okay. Okay, the figure below shows a compound strip of copper and iron. Strip is straight at room temperature, and the coefficient of thermal linear expansion of copper is greater than that of iron. So basically, what that means is copper expands more than iron. So if copper expands more, then this one will be longer, so it's gonna bend up like this, and this one's like it's a bit shorter. Okay, so and if it was cooled, it would bend down, because it also like it contracts faster too. Okay, anyways, this is chapter 1. Okay, now a red woolen jacket seals for black coal in an insulated room. They will all be the same temperature because they're the same room, and there's no energy loss. What happens when two objects reach thermal equilibrium? Yeah, heat transfer stops. Okay. A filament lamp emits radiant energy, so radiation, radiant. Okay. Gets hot when the bulb is switched on, heating it is in contact, so touching, so it's conduction. As it gets hot, the density increases, rising and cool, replaced by cooling. So it's basically convection, where the air rises, then goes down, so it's convection. Consider four charged objects such that ABCD, such that A repels B and it attracts C, and C repels D. If D is positive, then charge of B is what? Okay, D is positive. If it repels C, then C has to be the same, so positive. So C is positive. And A attracts C, they said. So A is going to be opposite, so negative. A repels B, so it will be the same, so negative. So B is negative, and negative with positive what? They attract. So yeah. The potential difference across the terminals of a dry cell is measured when a variable current is drawn from the cell. The potential difference is 5.5 when the current is 1 and 5 when the current is 2. They want the internal resistance. Okay, since this is a variable current, so it's changing, we can't just do V over I, because for this one you get 5.5 over 1, and that one you get 5 over 2, which are not equal. So what you have to do is imagine it's the V, what's it called? IV line, my bad. And it's a straight line. The slope will be 1 over R. So we find the slope of this line. So 1, 2, 5, 5, 5. So do 2 minus 1 over 5 minus 5.5. What do you get? Get negative 1 over 0.5. This is 1 over R, so R will be equal to negative 0.5. Okay, but negative doesn't really matter, it's just 0.5. Okay, now the potential difference when no current is drawn is what? So for this one we need to write the equation as if it's y equals mx plus b. So v equal to, what's the slope? It's negative 1 over 0.5 times it's I times v plus a constant, okay, plus b. Negative 1 over 0.5 is negative 2, negative 2v. And now they want the potential difference when no current is drawn. First, we need to find b. Let's substitute a point. We have 5.5 and 1. So 1 is equal to negative 2 times 5.5 plus b. 1 is equal to negative 11 plus b. So b is equal to 12. Wait, I did a mistake, I think. Okay, let me go back. 1 is equal to negative 2 times 5.5, so 1 is equal to negative 11 plus b. B is equal to 12. Okay, that's correct. And plus 12. Now we can answer, they want the potential difference V and no current. So 0 is equal to negative 2V plus 12 2V is equal to 12, so V is equal to 6 volts. Okay, so basically in these questions use the slope because it's not an ohmic conductor. I mean, they didn't tell us, so we can't just assume. With an ohmic conductor, you just do V over I. It will be constant for every value. Okay, when an electric emerging heater is connected to the 110 volts main supply, current of 50 amperes flows through it. The water tank contains 100 kilograms of cold water at 30 degrees Celsius. Assume the tank itself has no capacity and is perfectly lagged. The specific heat is 4.2 times 10 power 3. The temperature after 1 hour is what? So we know what do we know about okay, so this is it. This is the time and this is the temperature. So we have what? IVT, MCT. So we have two rules we can use. So we have Q is equal to IVT and Q is equal to MC delta T. The Q is going to be equal, right? Because the same energy that you use to power it up is going to be the same energy that heats up the water. So we're going to put MC delta T equal to IVT. And let's isolate delta T, so delta T equals to IVT over MC equal to 50 times 110 times 1 hour is 3600 seconds all over 100 times 4.2 times 10 power 3. You're gonna get okay, so variable resistors are called rheostats or potentiometers. Match each description to its corresponding term to differentiate between rheostat and potentiometer. Potentiometer is the one for the voltage, rheostat is for the current. Potentiometer is 3 terminals, rheostat is 2, and yeah, one is voltage, one is current. Let me summarize this. Okay, two resistors of resistances 2 and 4 ohms connected in series across a battery of 1.5 dry cells. An ammeter shows a current of 0.5. The total potential difference is what? It's not 1.5 because they said cells multiple, so we don't know how many there are. So we use, so they give us resistances, and I use V is equal to IR. The total, so it will be the total current, which is the same in series, so 0.5, times the total resistance. In series, you add the resistances, so it will be 2 plus 4 to 6, so it will be 6 times 0.5 is equal to 3 volts. 3 volts. Okay, a 1.5 volt dry cell is connected to light bulb with resistance 3.5. The current is what? So I is equal to V over R. 1.5 over 3.5. You can get 0.42 whatever. You round it up, it will be 0.43. Now the other one, you have current, you have resistance. So your V is equal to IR. So 6.25 times 17.6 equal to 110 volts. Okay, 3 electric cells, each have EMF 1.5 volts, are connected to form a battery. Battery, when the cells are in parallel, is 1.5 because in parallel voltage is always equal. In series, you add the voltages. So 1.5 times 3, which is 4.5. Then when two cells are in opposition to the third one, okay, so they said that two are in opposition. So imagine that it's 1.5. Wait. So the total would be, so the two cells will be 1.5 plus 1.5 minus 1.5. So we're gonna get 1.5. Okay, it doesn't matter the sign you pick because it will pick the direction of the stronger cells. So if let's say you chose 1.5 minus 1.5 minus 1.5, you're gonna get negative 1.5, but it's in the direction of the two cells, so just say 1.5. Okay, just ignore what I said, it's like overcomplicating it يعني. Just don't like put a sign, don't put negative or whatever. The following are tabulated results for the current through a resistor and the potential difference across it. Based on the relation, is it an ohmic conductor? For the ohmic conductors, the resistance is equal in each case. So we do R is equal to V over I. 20 over 12 is, 12 over 20 times 10 to the negative 3 is equal to what? 10 to the negative 3 because milliampere. You get 600. And then if you do for the rest, you also get 600 for each one. So you can say it's an ohmic conductor. And what's the resistance? We just found it at 600. Now they want the resistivity given the length and cross section. We know that resistivity is equal to, resistance is equal to resistivity times the length over the area. So to have that alone, you do resistivity is equal to RA over L. Okay, so resistivity will be equal to the resistance 600 times the cross section 0.2 times 10 to the power of negative 6 because millimeter is 10 to the negative 3 squared is times 2 6 over the length is 40 times 10 to the negative 2 passes in centimeters. So you're gonna get you get 3 times 10 to the negative 4. Here's the answer. Okay, current is current is 2 amperes and resistance is 50. They want the voltage potential difference. You know, V equals to IR, so is equal to 50 times 2 to 100 volts. The amount of heat liberated, amount of heat, energy, whatever, it's Q. Actually, it's better to call it W because Q is for charge. Okay, anyway, the time is 3 minutes. And you know that work is equal to IVT. So you do 100 times 2 times 3 times 60 to make it seconds. So you get 36,000 joules. In kilojoules, you divide by 1,000. Okay, the graph below shows how the potential difference varies with the current. If you remember from the graph I drew, this looks like a filament lamp, but here it says thermistor for some reason. Thermistor is supposed to look like this, so I don't know why. Maybe it's a mistake, or maybe they meant a PTC thermistor, which is the same as the filament lamp, but they didn't specify. They were both in the same choice, so I don't know why. Anyway, for part B, the resistance of the circuit element is what? You do V over I, so 5 over 0.1 is 50. Or you could choose any other point here. The resistance of 1 is 60. This is of 2 is 30. This is of 3 is 50. And this is 14 volts, they said. Okay. The equivalent resistance in 1 and 2 is what? It says it's parallel, so 1 over 60 plus 1 over 30 equals to 1 over 20. This is equal to 1 over R equivalent. So then, R equivalent will be the reciprocal to 20 ohms. Now, total resistance. Now we act as if this is 1, okay, so this is 20, okay. Now these two are in series, so 20 plus 50, 70. The current passing through resistor 3 is what? Since 3 is in series, so we do like the other question, we find the total current that can be equal to this current. So V total is to total current times R equivalent. So 14 equals to I times 20, so I is going to be equal to 70, my bad. So 14 over 70, 0.2 amperes, which is equal to the current in 3. Here's the potential difference across 3. Now we use V equals IR using the resistance of 3. Resistance of 3 is 50, I think, right? It's 50, so 0.2 times 50 10 volts. Okay, a voltmeter measures a maximum voltage of 10. Resistance is 2000, and a shunt resistance is used to modify so it can read 50. It should be in series. Yes, in voltmeters it's in series, in ammeters it's parallel. So find the resistance of the shunt resistor. The resistance, this one, it's RC. Wait, let me graph it. It will be like this. So current going in. This is our shunt. This is our C. And okay, so it's in series, so the current will this current will be for both of them. Now the voltage, it was originally 10. Without the shunt, it was 10. So we can say that the voltage across C was 10. Okay, and they wanted to increase it to 50. So they want the whole thing to be 50. V total is in series, it's additive. RC plus, VC plus V shunt. So it will be 50 is equal to 10 plus V of the shunt. V of the shunt is equal to 40. Now, we know the current. Actually, we don't know the current. Let's find the current. We can find it from RC. So 10 equal to 2000 I. So I will be equal to 5 times 10 to the negative 3 amperes. Now you know voltage of shunt is 40 and current of shunt is 5 times 10 to the negative 3. Now we can find the resistance. B equals to IR. So 4 is equal to 4 or 40. It's 40 equal to 5 times 10 to the negative 3 R. 40 over 5 times 10 to the negative 3, which is equal to 8000 or 8 kilo omega. Okay, if you don't want to do all of that work, you can memorize this rule. In my opinion, the other way is easier. But yeah, and if you don't want to do the work, you can just use this formula. Okay. They want the brightness of the bulbs. Okay. This current is in this light bulb is in series. It will have greater current than the ones in parallel. So it will be greater than of 2 because it gets divided up. Okay, and 3 and 4 are equal because they're on the same they're in series with each other. Okay, and no current will flow in the circuit if one is unscrewed. Yes, because current flows this way. If it's broken off, then none of them can work. If, for example, 2 was unscrewed, then 1 will work, 3 and 4, because 2 is alone. Okay, if bulb 2 is unscrewed, the brightness of bulb 1 is still the same because it's not in the same, they're not in series with each other. Okay, and 3 will become 0, of course, obviously. EMF across this both sides is what? Each one is 1.5, so these two are facing the same direction, they will be 4.5. This one in the opposite direction, 1.5 minus, you're gonna get 3. Ratio of the potential difference across the conductor to the current source is called the resistance. So V over I equals R. Yes, that's correct. It's an ohmic conductor, so they want the potential difference, so we have V, we have R, they want I, so I is equal to V over R. So 12 over 50 equals to 0.24. Now they want the resistance of the wire given the resistivity, length, and cross-section area. So R is equal to 0.48 times the length, which is 5 times 10 to the negative 3 over 1 times 10 to the power negative 6. Again, I'm just converting the units to meters. So 0.48 times 5 times 10 to the 3. You get 2,400. In kilo, you divide by 1,000. Okay, so that's the end of the quiz. Good luck on your exams. Bye.